Hi everyone, today we are going to learn how to factor trinomials that have a GCF or a greatest common factor that we would take out first. So remember, trinomials, that word trinomials, it's something we did last week, and it's a polynomial that has 3 terms. So something kind of like this. And we learned how to factor those last week. Now we only did trinomials last week that looked something like this, where the first term did not have a number in front of it. Technically this does, right? This has a 1 in front of it. But all of the ones that we did last week were just like this, where that first number is just a positive 1. Today we're going to look at some that have a coefficient in front. And we're going to learn how to take out a GCF, which we already know how to do that as well. We're going to learn how to take a GCF out of a trinomial and then completely factor it. And just a reminder, GCF, that means greatest common factor. So that is something we learned a couple weeks ago, greatest common factor. And we'll talk about the GCF in just a little bit. But for now, let's just review what we did last week. So we are going to factor these trinomials just like we did last week in the videos that you watched last week. So in the first one, remember that if you have a trinomial and it's written in this format, if you want to factor this, you are trying to put it into these 2 binomials, and you're trying to figure out, what numbers would go inside of here. And the way that we did that last week was we started by looking at the last term, and we figured out all of the factors of that number first. So 1 times 34, or we could do 2 times 17, and that's it, right? Those are the only things that go into 34. And then you would want to pick the factors that would add up to this middle term here. So which of those would add up to 19? Well, that would be 2 and 17. If you add those up, that equals 19. So we would factor this by writing it as x plus 2 and x plus 17. You could do it the other way around too. You could switch these up if you want to. All right, so that's the first one. And in the second one, this one has a negative on the 12, so make sure you're careful with that. So again, we're going to list out the factors of 12. So 1 times 12, 2 times 6, 3 times 4. And remember, because this is supposed to equal negative 12, that means one of our factors is supposed to be negative. So we have to figure out which one that would be. Now I need them to add to 4. And the only way to get positive 4 out of this is to use these factors right here, 2 and 6. And if I want it to equal positive 4x, then I would need to put the negative on the 2. So then we would factor this as x minus 2 and x plus 6. So that's just some review from last week. Now, if you remember, all of the trinomials that we dealt with last week did not have a number in front of this leading term here. It was just x squared, right? The number there, or the coefficient there, would technically be 1. So everything we've done up until this point with trinomials, that leading number there was just a positive 1. And today we're going to look at trinomials that actually have a number in that spot. So trinomials in standard form, they're always written as this, ax squared plus bx plus c. Now, of course, a, b, and c, those are usually numbers, right? We usually see some sort of numbers there. And again, last week we were only looking at trinomials where this a was equal to 1. Today we're going to look at some trinomials where that actually might not be the case. So there might be a number in front like that. We might also see trinomials that don't look like x squared. Maybe it has x cubed or something weird like that. So we're going to see some different stuff today, and we're going to learn how to deal with that. So let's go ahead and look at our first example. All right, so this trinomial looks different than the ones that we did last week because there is a 5 in the front here. Now that means we can't do the trick that we did last week where we just find factors of 10 that add up to 15. And even if you tried to do that, you'll see that it doesn't actually work in this case, right? There's no factors of 10 that would add up to 15. So before you try to factor a trinomial, the first thing that you always want to do, no matter what, is look at the 3 terms and try to determine, is there a greatest common factor? Is there something that I could factor out first? So that is always the first step. Factor out the greatest common factor first. And in this case, the greatest common factor, if you look at all 3 of these terms, Well, 5 goes into all 3 of those numbers. So the GCF here is 5. And that means we're going to factor that out of the trinomial. We're going to take it out. So that's going to go on the outside. This is just like when we learned how to factor out a GCF a couple weeks ago. It's the same exact process. So we're factoring out the 5, which means I'm going to take it out of all 3 of these terms. I'm going to divide each of these terms by 5. So let's see what we would have left. If I take it out of the first term, well, then the only thing I would have left is x squared. If I divide the second term by 5, 15x divided by 5 is positive 3x. And then if I divide this part by 5, 10 divided by 5 is 2, so positive 2. And you'll see what we have left. We have 5 on the outside, and then we have a trinomial in parentheses. And this trinomial looks like the ones that we were doing last week, because now if you ignore this 5 on the outside and you just focus on this trinomial, you have a trinomial that's written in the correct format where there's no number in front of this x squared, right? So we can go ahead and factor this the way that we normally would do. So we are going to list out the factors of 2. Well, that's pretty easy, right? There's only one thing that multiplies to 2. 2 times 1. And let's just double check. If you add those together, would that equal 3? Yes, it would. So we would go ahead and write out our factors. So x plus 2 times x plus 1. And then the only difference is, because this 5 was already factored out, we also have to bring that down and keep it on the outside. So this right here is the final answer. This would be the completely factored form. So in this case, we actually have 3 factors. This trinomial has 3 factors. It has the 5 on the outside, it has x plus 2, and x plus 1. So the only difference between this and what we learned last week is that you're taking out a greatest common factor first, and then you're factoring the trinomial that you have left over. So that's the process. So again, factor out the greatest common factor first, and then you just factor the trinomial just like we normally would do. Let's do some more examples. All right, so in this first problem, again, first thing you always want to do is try to figure out the greatest common factor. So let's take a look at all 3 of these terms here. Well, it looks like 4 would go into all of these, right? So 4 goes into 4, 4 goes into 32, 4 does go into 60. And if you didn't know that, you could just try to divide 60 by 4 and see if you get a nice whole number. So let's go ahead and take the 4 out. So we're going to write the 4 on the outside, and then we're going to write down what we would have left. And all you got to do is divide each of these by 4 and figure out what you would have left. So on the first term, the 4's just cancel because 4 divided by 4 equals 1. So we would just have x squared left over. 32 divided by 4 is 8, so that would be positive 8x. And then 60 divided by 4 is 15, so plus 15. All right, and now we are actually not done. So remember, you have to try to factor this trinomial if you can. So we're going to try to factor that. So our final answer should look something like this, right? We're going to have the 4 on the outside, and then we're going to have these 2 binomials. We just have to figure out what's supposed to go in there. So let's go ahead and do this like normal. And this is just what we did last week, guys. So we're looking at the last term here. So that's 15. And what multiplies to 15? Well, we could do 1 times 15 or 3 times 5. And which one of those would add up to positive 8? Well, that would be the 3 and the 5. And they do both need to be positive in order for this to work, right? I want them to multiply to equal 15 and add up to equal 8. So they both need to be positive. So we're going to write out our 2 binomials, x plus 3 and x plus 5. And that would be it. So this right here, all of this would be our final answer. All right, let's take a look at that next one. So go ahead and try to figure out what the greatest common factor would be. So take a look at all 3 terms here. Try to figure out what number goes into all 3 of those. And it is 8, right? 8 goes into all 3 of these numbers. So we're going to go ahead and take the 8 out. We're going to write that on the outside. And we're going to see what we would have left. So let's see. If I divide each of these by 8, I would have x squared left right here. 56 divided by 8 is 7, so minus 7x. And then 48 divided by 8 is 6, so plus 6. And then we're going to go ahead and factor this remaining trinomial. So again, I'm going to have the 8 on the outside, and I'm going to have my two factors here. And let's see, 6 is either 1 times 6 or 2 times 3. And I need this to add up to a negative 7. So the only way for that to work, so 1 and 6, right? 1 and 6, if you put those together, that equals 7. But I want it to equal negative 7. So they both need to be negative. And that does work, because if you multiply both of these, you're going to get a positive 6. And if you add both of these, you're going to get a negative 7. So we're going to go ahead and write out our two factors here, x minus 1, x minus 6. And I do want to mention, if you forget to put the 8 on the outside, it is going to be incorrect. That 8 is very important. It was part of the problem to begin with, right? So you can't just make it disappear. A lot of times students forget to bring that 8 down. So you will have these two factors here, but you're also going to have that GCF on the outside. All right, so let's take a look at this one. GCF. So let's see. Typically, it is going to be whatever that leading number is. So let's see if that's the case. Does 3 go into all three of these? Yes, it does. So we're going to go ahead and pull the 3 out. And then we're going to write down what we would have left. So if I divide each of these by 3, in the first term, I'm only going to have a squared. On the second term, 18 divided by 3 is 6. So that's going to be minus 6a. And then 21 divided by 3 is 7. So minus 7. And then we're going to go ahead and factor this trinomial. So we'll have the 3 on the outside, and then we'll have our two factors here. And let's see, if we look at 7, well, that needs to be negative 7. The only thing that multiplies to 7 is 1 times 7. And one of those has to be negative. You just got to make sure you do the right one. Now I need it to equal negative 6. So the only way I can get these two numbers to equal negative 6 is to put the negative on the 7. So we're going to do a plus 1 and a minus 7. All right, and then this last example, this one's a little different. So first, you will notice if you just look at the numbers, just like we were doing before, 5 does go into all three of those, right? So we can pull the 5 out just like normal. But in this case, you can also pull out one of the m's, because every single term has m in the term, right? Now we can only pull out one because this one only has 1 to give up. So we're going to pull out one of the m's. So we're also going to put an m on the outside here, 5m, and then we are going to write down what we would have left. So let's divide by 5m, divide by 5m, divide by 5m. All right, in the first term, well, the 5's would cancel and one of the m's would cancel, right? If you're doing m to the third divided by m, remember you can just subtract the exponents. That would be m squared left over. All right, let's do the second term. 30 divided by 5 is 6, so I'm going to write plus 6. And again, one of the m's would cancel, which means I have 1 left over, so plus 6m. And then in the last term, 35 divided by 5 is 7, so we're going to put minus 7. And the m's would just cancel, so there would be no m on the last term. And this is exactly how we expect it to look, if it's going to be similar to the other problems we did, right? This remaining part here, that is a trinomial. I know it's a trinomial because it has 3 terms. It starts with m squared, right? As long as it has that first term as a squared and the middle term is just a 6m to the first power. As long as it looks like this format, we can factor it just like we have been doing. So let's go ahead and do that. We'll put our 5m on the outside, and then we'll put our 2 factors here. And let's see, if I do negative 7 is only 1 times 7. We just got to figure out which one of those should be negative. And this time I want that 6 in the middle to be a positive 6. So I need to put the negative on the 1. So this would be m minus 1, m plus 7. And this would be our final answer here. Okay, so let's take a look at these last two examples. We're going to look at some where the leading coefficient is negative. So if that leading coefficient, and all that means, leading coefficient just means the very first number in the front here. If that first number in the front is negative, you always want to take out that negative. So only if the first part's negative. It doesn't really matter if there's negatives over here, but if that first term is negative, you want to take out that negative. Whether there's a number there or not, you want to take it out. So in that first example, it just says negative a squared. And we know that this negative here is technically a -1. So if I'm looking for a GCF, there really is not a GCF between these three numbers because there's nothing that goes into 1, 2, and 63 besides 1. However, since that leading term is a negative number, that is going to be our GCF. So we're going to take out the -1. Now you could write the 1 if you want to, but typically when you're taking out -1, you don't have to write the actual 1. So I'm just going to take out the negative. And in order to do that, you have to divide all of these terms by -1. And the only thing that's going to do, it's just going to change the signs of all of these, right? If you divide this by -1, that's just going to become positive a squared. If you divide the middle by -1, that's just going to become positive 2a. And then if you divide the last by -1, that's going to become a -63. So the only thing that happened once we pulled out the negative, it just changed the signs of all these, right? This part became positive, this part became positive, this part became negative. Okay, and we're still not done, remember, because you always need to try to factor this trinomial if you can. So let's see if we can factor this trinomial. Let's list out the factors of 63. So what multiplies to equal 63? Well, let's see. We could do 1 times 63. We could do 3 times 21. We could do 7 times 9. And do you see any factors yet that would add up to 2? So we want it to add up to positive 2. And it looks like 7 and 9, right? 7 and 9 would work as long as we put the negative on the 7. So let's go ahead and write out our factors here. Don't forget to bring down this negative on the outside. So we're going to have negative and then a minus 7 and a plus 9. And that would be our final answer. All right, and in the last example, this one actually does have a number here, right? -3. So we do want to make sure we take the negative with it, though. So let's make sure. Does -3 go into all of these? And yes, it does. So let's go ahead and put it on the outside. So we're going to put -3 on the outside. And then we're going to divide everything by -3. And be careful with your negatives here. Remember, when you divide a negative by a negative, it becomes a positive. All right, in the first term, well, those would cancel and we just have x squared. In the second term, -9 divided by -3. That's going to become a positive 3x. So we're going to write plus 3x. And then same thing over here. We've got a negative divided by a negative. So -6 divided by -3 is positive 2. All right, and then the last step, let's see if we can factor this trinomial. So it looks like we can, because if you look at the last number, 2 is just 2 times 1, and if you add those up, it does equal 3. So we would go ahead and write out our factors here, x plus 2, x plus 1, and make sure you put that -3 on the outside. All right, and that is it for today's video, guys. Let me know if you have any questions. See ya.